We are Team 11239B from Our Lady of FATIMA in Seattle, Washington. I'm Colin.
I'm Basil.
I'm Logan.
I'm Ethan.
And I'm Brendan.
We decided our challenge would be to show how the advancement of robotics, machine learning, and artificial intelligence assist in scientific weather data collection to help improve weather forecasts.
We thought this topic would be a good idea to show how even slight improvements in scientific weather data collection for weather forecasts would be beneficial.
We divided research responsibilities amongst our team and then came up with a plan and timeline to keep us on track.
Then we reviewed our challenge topic, research, timeline, and interview questions with our school's science specialist, Mr. Verhoff.
And came to a hypothesis. Our hypothesis is that improvements in robotics, machine learning, and artificial intelligence play a bigger role in scientific weather data collection, which would improve weather forecasts, which will help better prepare our communities.
How these improvements will help improve weather forecasts and modeling is what we needed to solve.
We went to the National Weather Service, a division of the National Oceanic and Atmospheric Administration, to speak with Kirby Cook, the Science and Operations Officer, to learn more about how meteorologists use the data they collect in forecasting. Weather forecasts are made by using robotic and satellite sensors to collect as much data as possible about the current state of the atmosphere and the understanding of the atmospheric process to determine how the atmosphere evolves in the future.
Data like atmospheric pressure, temperature, wind speed, wind direction, humidity, and precipitation are collected multiple times a day from trained observers using weather balloons, autonomous weather stations, Doppler radar, or weather buoys. This info is used with a numerical model's most recent forecast for the time that observations were made to produce the meteorological analysis. Numerical weather prediction models are computer simulations or weather models of the atmosphere. They take the analysis as the starting point and evolve the state of the atmosphere forward using understanding of physics and fluid dynamics. The output from the weather prediction models provide the basis of the weather forecast. The complicated scientific equations require supercomputers to solve them, and NOAA has some of the largest supercomputers to collect scientific weather data on the planet.
All of the meteorological professionals we interviewed said that the Pacific Northwest is one of the hardest areas to predict weather because our weather comes directly from the Pacific Ocean, so they have to use satellites and radar for most of the data to produce weather models. The development of advancements in autonomous robots for data collection and artificial intelligence would make weather modeling in our area more reliable and advance prediction accuracy.
While at the National Weather Service, Mr. Cook gave us insight into two advancements that are in development that are helping to collect scientific weather data for additional prediction accuracy. One of those is an autonomous sail drone by Sail Drone Designs, a private sector group manufacturing and operating a global fleet of unmanned service vehicles that combines wind-powered propulsion technology and solar-powered sensors to perform in-situational autonomous long-range data collection.
The other is NOAA's Artificial Intelligence Strategy that was released in late 2019 and is in draft for review and feedback right now. As the strategy explains, the NOAA AI strategy will dramatically expand the application of AI in every NOAA mission by improving efficiency, effectiveness, and coordination of AI development and usage.
And this was substantiated by Tridib Dutta, data scientist at Nest Motion Software, and Walter Kelly, chief meteorologist at Q13 News. Mr. Dutta noted that there are two common types of AI, linear regression and neural networks. Simply put, linear regression is a simple mathematical set where A plus B equals C. Neural networks is a highly nonlinear algorithm used for more complex data sets and is the machine learning portion of artificial intelligence. You show a program 1,000 pictures of a severe weather model and it learns to recognize the characteristics of what that weather model is and know what that particular weather model is not.
Mr. Kelly showed us the weather models he uses and how he uses them to create forecasts, a combination of weather models and his knowledge of meteorological science. Sometimes meteorologists will predict a weather event, but if it happens or doesn't happen, it's called verifying, which is also a form of AI. The computer model will verify whether what they predicted actually happened and will learn from that.
And Mr. Cook at National Weather Service said that weather forecasting is an ideal use case for AI, because there is a treasure trove of historical and currently available weather data in their supercomputers, which can feed data into algorithms that literally require both quality and quantity of data in order to be more effective at matching past occurrences with future prediction.
In conclusion, robotics and artificial intelligence will make weather predictions more efficient and provide greater local detail, provide everyone better forecast predictions to improve preparedness for the protection of life and property and the enhancement of the national economy.